Hey everyone, Notes 5.4 are on proving trig identities, and this is the first day of proving trig identities. And if you remember from last year, our goal is to show that the left side is going to equal the right side. That's our goal right here. And sometimes we'll play around with only the left side, sometimes we'll play around with only the right side. Sometimes we'll play around with both, but everything always has to stay on the same side, just like we said in Notes 5.4. So in the first example right here, I could do some work on the left side or I could do some work on the right side. The right side here is negative sine x. That's pretty simple. So there's really not a whole lot that I can do with this right side. So I'm going to try to play around with the left side. So the left side is equal to cosine of pi over 2 plus x. And you might have to flip back and forth between either the previous page or the front page, the back of the front page. But we have our formulas right here that we can use. And we know that the cosine of x plus y is equal to the cosine of x times the cosine of y minus the sine of x times the sine of y. That's just a formula that we know. And this looks the same. So I can say that this left side is going to be equal to the cosine of pi over 2 multiplied by the cosine of x minus the sine of pi over 2 times the sine of x. And now I can just see if I can evaluate anything. I know that pi over 2 is right here, and I know this coordinate is 0, 1. So I know that the cosine of pi over 2 is 0. And then the cosine of x, I don't know what x is, so I'm just going to write it as x. And then here, I know that the sine of pi over 2 is the 1. It's the y value, so I'm going to write down minus, and then I would get 1. And then I have the sine of x left over right here. And anything times 0 is 0, so this whole thing turns into 0. And then negative 1 times sine of x is negative sine of x. So when I subtract it, I get negative sine x, which is exactly what the right side says. So now we can say, therefore, the left side equals the right side. And then we use this symbol right here, which means that the proof has been shown. And sometimes some people will write down QED, which also means that the proof has been shown, but this is in Latin. And that's it for the first question. All right, in our second question, we have our two sides right here. We've got the left side, and we also have the right side. And it's a little tricky to kind of figure out which side I want to start off with because I do have a formula for the cosine of x minus y, so I could replace that with a formula. And I do have a formula for the cosine of x plus y. But on the other side, I can also rewrite tangent as sine over cosine. So just a reminder, we know that the tangent of theta is going to be equal to sine over cosine. This is stuff we already knew, okay? So right here, I'm going to play around, figure out some stuff on the right side first. So for our right side, we know that this is 1 plus the tan of x, tan of y, all over 1 minus the tan of x, tan of y. And I'm going to rewrite this using sine and cosine. So this is going to be 1 plus this right here, the tan of x is going to be sine of x over cosine of x. And the tangent of y is going to be sine of y over the cosine of y. And then in the denominator, I'm going to have 1 minus, and then same thing here. I know that the tan of x is sine of x over cosine of x. And I know that the tan of y is going to be sine of y over cosine of y. Now, because we're multiplying, we can just multiply straight across. So we can just multiply sine of x by sine of y over cosine of x times cosine of y. And I can do the same thing in the denominator. So I've got a complex fraction. I've got fractions within fractions, which I don't like. So the next thing I'm going to try to do is multiply by my LCD. And my LCD is going to be cosine x cosine y. And I multiply the numerator and the denominator by this right here. So if you notice right here, I got to distribute this cosine x cosine y to this one right here. And I would get cosine x cosine y. And then when I multiply this cosine x cosine y by this entire fraction that we have right here, this cosine x will cancel out, the cosine y will cancel out. So I would end up getting right here just sine of x times sine of y. And then I want to do a similar thing in the denominator. So when I multiply, I'm going to put this in brackets so I know it's the whole thing being multiplied through. And when I multiply cosine x cosine y by 1, I get cosine x cosine y. And then here, these cancel. So I have sine x sine y left over, but there's a minus sign now. So minus sine x sine y. Always keep looking back and forth between the left side and the right side. So our left side right here says cosine of x minus y all over cosine of x plus y. So let's go ahead and use that information right here. And I have formulas for these guys right here. So cosine of x plus y is this formula, cosine of x minus y is this formula right here. So I can say that this numerator is going to be cosine x cosine y minus sine of x sine of y. And then in the denominator, oh, and I'm sorry, this should be plus right here. And then in the denominator, we have cosine x cosine y minus the sine of x sine of y. And if you notice right here, our left side looks identical to our right side. So we have proven this trig identity right here. So we can say, therefore, the left side equals the right side. So we have done our proof, or we can just say QED, and we are done with this right here. Okay, another option is you can just keep working on the right side and use this to say that it's equal to cosine of x minus y, and write this to say that it's equal to cosine of x plus y, and then leave the left side exactly as is, and then you would still have shown that the left side is equal to the right side. All right, our last example that we have for today is number 3 right here, and we want to prove this right here. And if you notice, the left side is a lot uglier than the right side, which means that I have more things to work with on the left side. So I'm going to try to deal with the left side first, and if I need to, I'll go to the right side and I'll work back and forth until I get to a point where I feel like I'm comfortable with things. So I'm actually going to write both of them down, and I might have to go back and forth between the two. On the left side, I'm not really sure what to do because there's just kind of a lot of stuff going on here. So I have a couple of options. I can either change these here into sine and cosine, but by having sine of 2x, don't write this down, over cosine of 2x here, and then having sine of 2x over cosine of 2x here, nothing's going to cancel out, nothing's going to simplify, so I don't think I'm ready to do that quite yet. I have another option of using the double angle formula right here, but again, I don't think that that's going to make things simpler for me. I feel like it's going to make things more complicated for me at this point in time. So what I would do right here is another option that I have. And again, the way I'm doing it is not the only way that you can do it. There's multiple ways you can do it. But if you notice, there is something in common here. And they're both, there's a common factor of tan of 2x. So when I take that out of this first term, I have a 1 left over. When I take it out of this term right here, I have a negative 2 sine squared x left over. And this should look familiar to you. And if we look back here, 1 minus 2 sine squared x is equal to the cosine of 2x. So now I can replace this expression right here with the cosine of 2x. And that's being multiplied by the tangent of 2x. And now that these have this 2x in common, it looks like things are going to be easier to look at. Plus, this is just generally simpler than the other one, than the original expression. Let's keep going with this and see if we can work with this a little bit more. Now, at this point, it might be helpful to change tangent into sine and cosine. So I'm going to say sine of 2x over cosine of 2x, and that would be multiplied by the cosine of 2x right here. And the more practice you get with these trig proofs, the more foresight you're going to see, where you're just going to kind of play around with things until you can get it to work for you. And I can just see right here that this cosine 2x and this cosine 2x cancel. So I end up getting sine of 2x, which is exactly what the right side is right here. So we can say, therefore, left side equals right side. We are done with this proof. You can use the square symbol or QED. It doesn't matter. They mean the same thing. We are done with this proof and this video. Let me know if you have any questions. I know trig proofs are hard, but you can do it. You're just going to have to push through it. Okay? All right. Have a good day. Bye.